Hi guys, hope you're all doing great. So today we're going to look at a different topic under errors. First, I'd like to request some of our members who have not subscribed to our different channels on YouTube and social media. So kindly go to YouTube and search Sciences and Mathematics or different topics that we are trying to discuss in this. Subscribe to our channel and try to follow us. Engage us on the comment section so that we can be able to have a healthy discussion. And also follow us on social media so that we can be able to have a link over these different topics that we are discussing. So for today, we're going to look at a propagation of errors. And as we have mentioned, of course, we're going to see that propagation of errors is simply methods that are used to determine the error in a value, where this value is calculated using two or more measured values with no estimated errors. So in this case, we have looked in our previous discussion in one of our videos, we talked about the estimation of random errors. And we said that the concept of estimation entails a rough calculation of values or rather quantities. And therefore we said that in order for us to try and figure out how we can be able to express our discussion for today, that is propagation of errors. These are methods that we're going to use in order to determine the errors in values, where the values is obtained by using two or more measured values with no estimation of errors. Therefore, if you try to say that we're going to do a calculation of two or more values, then therefore this is going to entail some of the basic operations that we have been doing for mathematics in calculation, which entails addition, subtraction, multiplication, and division, which are going to assist us in trying to perform this concept of propagation of errors. So therefore, I'm going to use an illustration or perhaps an example, hypothetical example, in order to try and discuss this specific concept. So therefore, I'm going to have these two examples for this one. So suppose we have x and y as measurements with determinate errors for x given using the expression as or rather for y given using the expression as, just use this lowercase, so given as y plus or minus sigma y. And then we have another one, let me just use this one. So if we have two specific measurements for these two range of values, so we have these measurements, and then we have what we call determinate errors, which are resulting from these two specific measurements, just the same as we have been obtaining some errors from a range of measurements. So in x, we are going to have a determinate errors x for x and y given as dx and dy, which are of course deviations from these true values, or rather from these values of x and y expressed as dx and dy. Now, if the result of these two specific individual measurements, perhaps if we say if the sum of all those two specific measurements is going to give a result of z, therefore we are going to have three specific expressions that are going to be used in order to denote the individual errors in this three range of measurements for the first, second one, and the total results for those measurements. Therefore, the combined effect is going to display a characteristic that is going to have expression that is containing those two specific errors. And therefore, the three measurements for the first one, x, is going to be given as x plus or minus the deviation in x. Now, in this case, we're going to use the concept of a sigma, delta, which is going to be given as, so this is delta. So therefore, the expression for this one is x plus or minus delta for x. This is for x. And then for y, we are going to have it as y. Let me just use uppercase. So y plus or minus delta y. And then for the total value, of z, we're going to have it given as z plus or minus delta z, given as such. So these are the three expressions that we can be able to use in expressing these specific measurements using the individual errors. Now, suppose we were to perform an operation that I talked about of addition, subtraction, multiplication, and division. We're going to see that these errors are going to be expressed in these particular calculations. And from this, we're going to look at a general way in which we're going to represent these specific errors for these specific operations. So the first one we're going to look at is addition, an operation for addition, whereby we're going to see that is if z is the summation of those two readings for x and y, and therefore we're going to express the total z plus the error in z given as x, and use these specific symbols to represent x plus delta x. So this is inclusion of all those specific errors which are going to be of course given in that case for x, and then plus y plus delta y. So this is the summation of our errors which have been given in that particular case. So we're going to have this element for x and the y being added to come up with the sum for z. And from this we can be able to do a rearrangement of that specific expression in order to try and see which section of this expression expresses the error or the number or the value that has been given. So therefore, if we have to do a rearrangement of this second part of the expression, so from this, the concept of distribution, a distributive rule that we have worked in some of our calculations from basic mathematics, we're going to see that we're going to use x as a with a distributive property for the second part of or rather this. No, we're not going to apply that one in that case. Sorry for that. So we're going to just open the brackets and try to rearrange this one and see what it gives. So if we try to figure out this particular section which does not contain errors, we just do a rearrangement for this and have the errors just given at the far end as such. So therefore, we're going to see that from this specific case, we had said that if z is a value that is not having errors, then it's going to be the sum of x plus y. So therefore, if you try to look at this first section of this expression, then therefore it's going to imply the z that is devoid of errors. And therefore, if you try to look at the second section of this particular case, it's a part that is containing that aspect of errors, and therefore we can be able to express that one and say that the summation of those errors, the total effect of those particulars in the element of x and y is going to be expressed using this total error here. Therefore, we can make a conclusion and say that this is delta z can be written as the sum of delta x and y. So therefore, this gives us the first indication of how we can perform an operation of addition using that concept of errors and try to figure out how that one can be expressed. And therefore, we're going to see that the determinate error that we're going to obtain in the size of two quantities for x and y is going to be the sum of the error in those specific quantities expressed as this. So that last statement basically implies this, that if we have two quantities which we are performing an operation of addition, with those individual errors, therefore we are going to see that the determinate error in the size of those specific quantities is going to be the sum of the errors in those quantities, and that basically applies to the concept of an operation that I've called addition. So this is the first set of how errors should be treated whenever we are trying to perform addition, insofar as data of this specific nature is concerned. So next we're going to look at how we can be able to perform an operation for subtraction and multiplication. Perhaps in our next video that I'm going to, of course, put a link of that in the description box. So catch us in our next video as we discuss about propagation of errors using subtraction, multiplication, and rather division of these quantities of x. and why. So that is it for now. Bye guys. God bless you.